Hi, and welcome to another math doubt clearing session. Today's question is from the topic of geometry. Let's read the question. Two equal circles of radius 4 cm intersect each other such that each passes through the center of the other. The length of the common chord is. Alright, so we have some information. First thing being that the circles are equal. So have a look on this side. This is the first circle. Let's name it Q. And this is the other circle, which is shaded in green. Let's name it P. Now, the colored portion that you are seeing in between is actually the region that's overlapped by both the circles' circumferences. Now, next, A is the center of circle Q, and this small b is the center of circle P. What we're supposed to find is the length of AB. Alright, so we need to find AB. That is the common chord. And just in case if you don't know what a chord is, so let's just take any circle and any line that happens to pass through the circle and cuts it at 2 points on its circumference is known as a chord. Okay, this should be the center. A chord that passes through the center, you should know this. A chord that passes through the center of the circle is known as? It's known as a diameter. Okay, so yeah, that's a chord. Now they're talking about not just any chord, but a common chord. That means that passes through both the circles. So AB is actually the common chord, and it's lying in the overlapping region of the two circles. How do we do it? We make use of the good old Pythagoras theorem. Which states that h square, that means hypotenuse square, is perpendicular square plus the basis square. Alright. Now this part is the 90 degrees. Okay. This is the 90 degrees. And A is the center of the first circle, circle Q. So if you draw a line from A to small a, you can see that you've got a triangle, namely A, small a, and C. That's your triangle. A, small a, and C. Right? Now we need to find AC. That means A and small c. You got to find this, because if you add AC twice, you would get AB, because it's apparent that AB is nothing but AC plus C and B, right? All we have to do is to find this portion, this area. How do we do it? So, capital A and small a. Look carefully. Capital A and small a is actually the radius. Because I just told you, any line that's drawn from the center and touches the circumference of a circle is the radius. So capital A and small a is a radius, and we are given that the radius of the circle is 4. So this portion is 4. Capital A and small a is 4. I'm going to write it here, 4. This part. All right. What is A and C? A and C, if you look carefully, this is the biggest circle. Let's take a different color to explain. This circle, this is the circle Q, and A is the center. So if you draw a line straight from the center to the circumference, that's a radius, right? And the radius AB, that is the center to the center, is 4. And when you intersect it right in the center at point P, you get two parts, AC and CB, where AC is actually 2. This part is 2, and this whole part is 2, because the entire thing is 4. This entire thing is 4. And we have just split it in half, so this part is 2 and this part is 2. Let's clear something. All right. Now, let's plug in the values for triangle capital A, small c, and c. So we know capital A and small a is the radius, so it's 4. Small a and small c is 2. So what would be capital A and small c? If we had to fit this into Pythagoras theorem, I would say capital A and small a is actually the hypotenuse. Small a and small c looks like the base. And we are set up to finding capital A and small c, which is the perpendicular. What do? We know that perpendicular square would be h square minus b square. So you plug in the values, 4 square minus 2 square. All right. And then you have to remove the square from p. So what do? You throw a root over their heads and solve it. So 4 squared is 16, and 2 squared is 4, and 16 minus 4 gives you a root 12. Okay? And if you simplify the root 12, you'll get 2 times 3 times 2, all of this under the root. So 2 and 2 comes out as a pair, and this 2 is thrown out, and 3 stays in the root. So your perpendicular is 2 root 3. What is the perpendicular again? It's the AC. It's the AC. And we know, over here, write down the picture. The AB, that's the common chord, is actually capital A plus small c and capital B. We just found the value for capital A and small c, which is 2 root 3. And CB, which is the same triangle, but on the lower side, this one is again 2 root 3. For this triangle as well, the perpendicular is going to be 2 root 3 because it's just the same triangle divided in 4 parts. So you get 2 root 3 plus 2 root 3, 4 root 3. That is the length of your common chord, which is 4 root 3.